A warm welcome to Visual Forum. This is a day to explore how digital twins can be used in innovative ways and how new applications can help us understand the future and change the way we work. We've provided an opportunity for you to interact with the speakers. So we are going to present now how we will use Mentimeter. If you go to www.menti.com on your phone or on a tablet and use the code 11 33 53 and 9 menti.com, and this will be the second screen that we will be using throughout the day. The first question to you is, what are you interested in? This is a kind of way to guide me when I present the guests with questions and follow-up discussions. So are you interested in practical applications and examples? Are you more interested in the technological aspects of solutions and technologies, future applications, or human-centered design, or new ways of working? And you can choose between one or several of these answers. I would also like you to stay on that question and scroll down in menti.com to where you find a what we call in Swedish pratbubbla, a shout out, and get a little bit more serious about yourselves. We'd like to know, what is the view from where you are sitting now? If you click that black pratbubbla, you will be able to tell us what's the view. Are you looking out over a beautiful foggy lake? Are you looking at your feet, half lying in your sofa? Or do you see a view over perhaps an office? Just to give us an idea of where you are. And I'd also like to return to that. Can we just have that image of what you're interested in? So practical examples and applications, basically evenly spread. We'll stay there for a little while. And some of you are looking over nature. One of you just saw your dog. Yes, we are looking into a time when remote working is inviting us to all kinds of environments. We're sending this from Visualisering Center in Norrköping. Visualization Center in Norrköping. So I'm looking out over screens and cameras, and behind me I have green screens and all the guests ready to provide you with examples and inspiring content for the day. So I'd like to start by kicking off and say that in a way a digital twin is like a cognitive companion, augmenting your ability to make decisions and think. And our first keynote speaker will focus on the long-term opportunities with augmenting digital twins with artificial intelligence. It's a great pleasure to welcome the Professor of Scientific Visualization from Linköping University, Anders Innemann.
So great. Thank you very much, Beata. It's a pleasure to be here.
Can I also invite you, all of you guests, to use Mentimeter for questions? If you just go to menti.com, you will have the next opportunity to interact, which will be opportunity for you to ask questions to Anders throughout your talk. Great. Sorry for interrupting.
No problem. Great. So thank you very much, and thanks for the possibility to come here and give a presentation. I have given it the title Augmenting Digital Twins. And my task here is really to try to give you an introduction to the notion of the digital twin, but also to provide you with a human context on that. to start off, I would like to show you a little bit about the background. So the technical background of the digital twin is really driven by some underpinning technological trends. Things like artificial intelligence, the deep neural networks, the big data explosion that we're seeing at this point, but also things like GPUs, the hardware that is driving the development for us in terms of infrastructure for computing. This is really a game changer for us in terms of developing what we call the autonomous and intelligent future. All over society you have the explosion of applications, of use of these technologies. And of course my role is to provide us with the human context and the interfaces to the human in this very exciting time of intelligence, of autonomy, of big data, of information. Now, the notion of a digital twin, if we start off from that perspective, now the twin is really a digital twin that is a digital replica of a living or non-living physical entity. Now, if you think about the aspects of the digital twin, I would say there are three different components in this. The first is it represents the historical past of something. It represents the current situation. And it also enables us to simulate the future. So in essence, it knows, it thinks, and it interacts. It lives in an ecosystem. Now, the digital twin in itself is some sort of container for a number of different aspects of development, technologies, information resources, capabilities that are contained inside of the digital twin. This is just an example of the various pieces of technology that you want to put into your digital twin. But I dare say that in some cases, we are forgetting to some extent the aspect of the human. The human interaction plays a central role in all of these technologies. And it's very important to think about the notion of how we are interacting with the systems. I could recommend one of these books that had come out last year that really reflects over the notion of the human knowledge, and in terms of scrutinizing the actual progress in terms of AI and machine learning, and the lack of the reasoning layer, the reckoning, the reflection over the situation and the future. And this is where humans excel, and how we can add, how we can augment the intelligent digital twin. This leads us also to the notion of developing visual interfaces to digital twins. Because as you know, the best way of getting a high bandwidth between the human and the computer is to use visual information visualization. That's why the visual interface becomes so important in the context of the digital twin and its interaction with humans. Now, this is perhaps the most important slide that I have here today. I'm placing the digital twin inside of the information loop where we have the humans. Now, we start off with simulation, computation, we have a digital twin engine, we have a human interface, and at the far end, we have the human insight, the decision, the planning that we need to make in terms of the digital twin. Of course, what we want to do is to connect that insight back into the digital twin through some sort of interface. We also want to connect it back into process control, knowledge, feedback to promote our knowledge with the digital twin. We also want to be able to have human insights affecting reality to steer the information gathering, agents, autonomous systems, simulation, computers, etc., etc. What is it that is happening now that's so exciting? Well, artificial intelligence is happening here. Systems are getting so smart that they can offload some of the things that we humans have been doing in the past. We're also introducing inside of the digital twin artificial intelligence to make it even smarter at that point as well. And the amazing capability of handling very large amounts of data very rapidly that machine learning is providing us with. And of course, the digital twin itself starts interacting with the environment in more intelligent ways. This is the game changer, and these are the points in the pipeline where we are now seeing a revolution in terms of technology and where machine learning is doing its best. This really calls out for a new system of human-in-the-loop technologies, because we are dealing with a higher level of intelligence. We need to develop new representations, higher level of abstractions, situational awareness, all of these things that you see in my list here, which is really topics of the research that we are doing at this point. How do we enable the human to interact in an intelligent, efficient way with the digital twin? A few examples, and you will hear more about this during the day here. If you look at things like maybe an instrumented urban environment, where we are looking at this particular aspect of the past, of the present in terms of sensor instrumentation in environments, but also looking at the simulated future. Another example, exciting example, comes from the Linköping University Hospital at the CMIV Center, where there's work going on in terms of developing digital twins of human hearts. Here you can see a beating human heart and the possibility to, in a patient-specific way, interact with his heart and even perform virtual surgery and look at the outcome. And here you can see the tremendously complicated setup behind all the information sources that goes into building up the digital twin, the intelligence behind thousands of human hearts that we are then driving in a machine learning model. Of course, I can't resist to put in the ultimate digital twin, which is, of course, the digital twin of the universe that we are working with here. In our open space project, we really had the enormous ambition to try to develop things like contextualization of scientific data, space missions, observations, simulations, and do these amazing storytellings that we can do about the virtual universe. Take you all the way from the space station orbiting the Earth out to the Big Bang, 13.8 billion light years out. Perhaps the ultimate digital twin. We call it 42, or open space. Here you can see an example of open space at work, where astronomers are interacting with their digital twin of the universe, looking at 1 billion stars together for the first time at the Hayden Planetarium in New York, using the software open space that we are developing here. I would like to finish off my presentation with a little bit of a scientific exploration into the future, almost, I would say, science fiction level. We are playing with the notion of representing the digital twin with what we call a cognitive human companion. This is all based on research that we have done in the past. It's Jonas Unger here, together with his colleagues in America, in Los Angeles, who have been developing the notion of stereoscopic images without glasses. You will be seeing during the day today some of the virtual reality equipments that are based on the eye separation between the left and the right. But if we look into the future, the next generation of display system is not going to have that limitation. You won't have to wear heavy equipment to get 3D images into your brain. Each of the pixels in the screen will become a light source that is directional. This means that we can get like a window to the virtual reality. The way we do that at the current point is kind of cumbersome, in the sense that we are looking at 216 projectors at the same time, all of them back projecting onto a transparent display. And if we do that, it looks like this. We have a virtual representation of a human being that looks like a hologram. At this point, it's video sequences. But in the future, the digital twin representation could be a human avatar. And that will enable us to actually have human-style interaction with the avatar. Here's an example, a captured human, where there's hours and hours of video material. It's actually, in this example, one of the survivors of the Holocaust. And there is a documentation of many, many hours. And you can ask, and the query answer system gives you answers to his experiences. And when you do that, it's actually like talking to a real human being. Of course, the vision here is to be able to let humans interact with their system, with their digital twin, by having a human dialogue with the interface that is very advanced, augmented with traditional interfaces at the same time. Current work is ongoing, so stay tuned from the lab here, Jonas Unger and his work, and you may see something like this coming out in the near future, which in research is, of course, 10 years. I would like to acknowledge all of the people who are contributing to the work we are doing here. I have an amazing set of staff, the representative of many, many smart people who are very energetic, doing amazing work inside of the center, and the organizations that are sponsoring us and that are hosting us as well. Thank you very much.
Thank you, Anders. As we saw in the beginning, our participants are interested in applications and use cases. What benefits do you see for organizations or companies working with visual technologies and interfaces in general?
Well, it's like I put out in my presentation. I think there's a lot of benefit to be gained from the use of the visual interface in many situations. It's sort of the cognitive offloading of the human brain. You know, the human body has our sensors, the information. More than 70% of the input sensors that we have is through the vision. And 50% of the brain is being activated when we are doing visual analysis. So it's really shortcutting the distance between the information and the human. And of course, what's happening now is that you can even more reduce that bandwidth that's needed with the help of intelligence that you're building into your systems.
And then what opportunities do you see when we do offload that cognitive load?
You can spend more time on the reasoning layer where computers are still not so advanced. You can spend more time reflecting, be more productive. But at the same time, you have the challenge. And I should say there's another side of that coin. And this is the problem that we have with the situational awareness. If you have situations when you have people like in an operator situation where you need to steer something that's happening in real time in reality, if the system manages that most of the time for you and something happens that needs your attention, how do you make sure that you pop back into that situation very, very quickly?
How do you?
Well, I mean, there are various ways of doing that. I mean, there's a gaming approach to that you can keep people entertained with the game, which is entailing information based on the system, but also other ways of providing that cue and do it as fast as possible to maintain that you don't lose that situation. And I believe that this is one of the big problems for instance, that we'll hear about today in air traffic control, where you need to maintain that situational awareness. I'm also encouraging you to go to menti.com and use our code 1133 539, and the slide that's open now is if you want to ask questions to Professor Innemann, that opportunity is available now, and I'll check the Menti. I have another question about, can you give us some more applications that you think that we'll be spending more time exploring going forward? I think we're seeing the pervasiveness of the digital twin concept and the intelligence that goes into that. And I think we're already seeing that in terms of services that are out there, automation, the layer. I mean, you are probably not aware of it when you're using some of these services that are today actually machine intelligence driven. So it's hard to say exactly which applications that will be there, but what I can say is that you need to place all of this in its proper context. And I think this is where I see the failures that I see. Let's spend a minute on failures. The failures that we're seeing are when there's some sort of overbelief that the digital twin, the intelligent digital twin, will solve all the problems. You need to put it in its context, and when you do that in a proper way, so you analyze and you see this is where we actually have a problem that we can solve using these technologies, then you have a route to success in terms of doing that.
So you know your problem, and then you work from there, and then you see how digital twins and how they can be augmented with AI, and that's just rational decision making. But is that pitfall that we think that, oh, we can do anything, just elaborate to see what we get without a proper a problem to address?
Right. I think that's one of the issues. But of course, the technology in itself is very hyped at this point. So it's also some sort of hype management in terms of being realistic about what can be. Swedes are very good at that in general, right? Usually we're a few years behind the rest of the world, but it also means that we can manage the hype a little bit better. So I think we're doing that. And we're seeing it, of course, we're seeing it in applications like in autonomous vehicles. We're seeing it to an increasing degree in healthcare as well. And I think the initiatives that we're seeing now on sort of data-driven life science is going to have a tremendous impact. I mean, what I showed you here about the human heart is just the beginning of how we can go down, all the way down, to gather the information down from the molecular level, from the genetic expressions, to protein level, to cell level, to organ level, and to human. And have all of that information in biology will enable both research and clinical practice as well.
So amazing. And you sometimes address or you label the digital twin your possible cognitive companion.
Right.
And I'm thinking, just from sort of an awareness and cognitive perspective, how will I interact? Will it be brain computer interface? Will it be some kind of kinetic signal? I mean, how are we going in real time to be assisted?
I think you will see all of the above, depending on the context where you're in. I'm excited about the brain-computer interfaces and the possibility of doing that communication. But I'm also very excited about the possibility of having human-style interaction, like you and I are interacting at this point. I think that's really where we as humans excel in terms of talking, gestures, voice, coughs, everything like that. It encodes the information, the discourse between us. And I think that's where we need to go if we really want to have an efficient human dialogue. But
to a very natural kind of interaction.
But of course it's very exciting to do all sorts of other things as well, with haptic, tangible interactions, all of those things. And we will see a lot of those technologies being evolved in the wake of this. And I'm sort of looking forward to, we had the first generation of virtual reality back in the 1990s, which failed miserably, as we all know. We have the second generation now. It's better, but it's still not there. So I'm looking forward to the third generation. When it's hyped the third time, maybe we get into the point when we can actually start deploying it at a larger scale.
The title of your talk is really where the human aspects come in. And where do we need more human intelligence? Where do we need to say, humans before technology? Which are the most acute areas where we really need to be careful?
I think that brings us to a very important aspect of this, and this is, of course, the legal, the moral, ethical aspects of intelligence as well. And we're not consistent. We're humans. I mean, we are not consistent in our decisions. So if we are not ourselves consistent in our judgment, how can we expect the computers to follow specific rules and call out the right decision? Because we're so depending on context, on interactions. The human brain is not consistent. It's fighting itself in different regions with different decisions all the time. And I think we need to be very careful in how we are developing the policies, the legal frameworks for all of these things. And there's a new initiative in Sweden by the Knut and Alice Wallenberg Foundation called the VASP-HS, which is exactly dealing with those kinds of issues. And it's very important. And I think if any country in the world can do some really exciting research in that domain, is Sweden, because we have a very solid foundation in terms of applications. We have access to data, we have access to people. So I think we can really be a forerunner in terms of developing that framework that we really need to be able to deploy these technologies at a larger scale.
And you're the director of that foundation, and if you had a magic wand and you could gather all the researchers and all the intelligence of the world, what is the critical issue that you need to solve to be able to have a way forward that is both innovative and ethical at the same time?
I think one of the keys to doing that, and this is what we're looking at now, and the VASP-HS is sort of a separate entity, and I'm more on the technology side, but to cross over between these two domains to form these multidisciplinary teams that can attack questions of that nature and do it in a technical aware situation, humanities aware situation. I think that's the key to solving some of those issues for the future.
And if we meet again, say in 1 year's time, what do you think will be the issues that we will be discussing that are high on the agenda?
I think time progresses very, very fast, and this is like a speed train that's running in this domain, so it's hard to predict. But in some sense, it's also frustratingly slow. So my prediction is that we will probably be talking about the same issues. From some perspective, there will be surprises, there will be disruptive things that are coming out in terms of applications primarily, I would say. And there will be surprising applications that we say, wow, did this really work? And we
Even
will
if,
see
if it's surprising, what could it be? Say, what would surprise you, for example, an area of an application that would surprise you?
I think we go back to this sort of the human, the mimicking of the human, the understanding. Actually, maybe that's one of the things. If I need to pick one thing that I think is needed from an understanding perspective, is how do you relate how the human brain works to what's actually happening inside of a machine learning algorithm? Can we understand that? Because today it's very much the black box of AI. And we need
that
to
we
open
just
up.
accept in
We
some
accept
way.
it, right? And we need to understand that better, how that actually works, and how do you relate that to the biology. That connection between biology and the understanding of machine learning, I think, is very exciting.
And that's why we need cross-disciplinary
Exactly.
teams. Thank you so much, Professor Innemann, for joining us today.
Great to be here. Thanks.
Thank you. Let's talk about long-term opportunities and societal benefits from 3D imaging. With us to talk about that today is also we're going to learn about how the Swedish police is exploring new opportunities. Research Director, Swedish National Police Authority, Lena Klasén. Please join me.
Thank you.
Hi, Lena.
Hi.
In 2017, the Swedish police made a 3D model of the terrorist attack at Drottninggatan in Stockholm. Let's take a quick look at that, and let's talk about what you've been doing here and what you hope to gain from a 3D model.
Yes, here we go from the high future vision, and we come back from the universe, as Anders talked about, and we go to real case. In prior to the terrorist attack at Drottninggatan, we were actually very, very well prepared at the Swedish National Forensic Center at the Swedish Police, because we have recruited excellent staff and we had bought a lot of equipment. So when the terrorist attacks occurred, we actually could go there and we can make a real digital twin for real forensic casework. So this showed the truck. We set up, this is a huge and large complex crime scene. So we had to measure at 93 different points and have a huge point cloud. And here we also could borrow a truck and make a 3D model of the truck. And here you can see the truck driving at
This is a pedestrian street where
Yes,
it's
yes.
driving very quickly.
And you can also see soon that he also will hit the line here. And this is this capture a crime scene, and you can see the speed, 63 km/h on this street is quite high speed. And here he actually breaks the truck because the hydraulic system doesn't work, so he end up in Åhléns. But this capture a moment, and the sooner you can capture a crime scene, the better it is. But this is still historical data.
Yeah. What were the actual benefits of, besides just capturing the crime scene? What was the actual benefits of the 3D model?
We, of course, think like forensics and we think like technicians, because we had a huge, large crime scene. We could support the forensics, we could support crime scene investigators, etc. But if you just move a little, this is you can see the picture here. This is actually one of the benefits, that we could show this video, and the near and dear to the person who were actually hurt or killed could see what happened. So beside using this in court and using this for analysis, it was very human-centric. Here you have human-centric in two ways. first you can see the perpetrator's view, as a centric from the perpetrator's view, and you can also see it from the victim's view.
It's eerie when you see it from the driver perspective.
Yes, it is.
It is.
Yes.
And then you elaborated on the model. What was it that you wanted to add?
What we really wanted to do is that this is a satellite picture from a company, Rikon here. So if a crime happens, we want to be there, we want to go there. And usually satellite pictures are not recorded at the same time as we want them to be. So we started a project and gathered 15 different partners with a lot of expertise in everything that Anders mentioned is important. You need AI skill, you need sensor, new high-tech sensors, etc., etc. So we went to Västervik and made a recording. And of course, we, as I'm from the police, we set up a artificial crime scene.
This has nothing to do with Drottninggatan, just to be clear.
So this is when we wanted to go beyond Drottninggatan and make a digital twin that could provide so much more information. Here we can go from the satellite view and we can go to close-up. What we don't see here is that we also have hyperspectral data and thermal data, which for us technicians is very important information. And we will soon see that you can actually go underground as well. This is a company called Astakust that provided a ground-penetrating radar system, which of course is a huge interest for us in the police, because we want to see if something is buried underneath the ground.
You could see if there were weapons, if there were bodily fluids here.
Yeah.
It's almost like you have a radar site here.
Yeah, you do, because you add more information. Because a normal 3D digital twin is just size and colors, but here you can add a lot of more information. So this is a typical picture that the researchers love. What you don't probably see directly is that this is a forest, and this is a forest as seen from above from a drone. And from the police, we want to find whatever there is in the forest that we want to find. So if we analyze
this is, for example, from the fire helicopter, they don't see anything, they just see smoke.
Yeah. So you want really, this is where you use artificial intelligence to find what is not supposed to be there. You can look for anomalies, or you can look for known signature of different elements. So this is actually some logs and some stones, which is perhaps not the most important in a crime scene, but in a firefighter situation, maybe you want to detect something hotspot or high-risk areas, or likewise.
How does this change the way you work?
It really has changed the way we work, because this is how it can look like in a real crime scene. We use this technology to capture a crime scene in 3D, using all kinds of different scattered light, LiDAR system, etc., etc. And as I said, this is not a real crime scene, because I cannot show those, and I do not want to show those, because we use it in murder case, explosive cases where they blew up buildings, etc. But here you can have a very high, accurate, and very detailed and precise model of a crime scene. And here is this is actually.
And it's really fast way to capture it too, because you're always working against time.
And also, the longer you wait, the more contaminated the crime scene can be. So as the earlier you can capture the crime scene, the better it is, because then it's more. It gives you higher value to when you analyze what actually happened.
How else is besides just working faster in the beginning of when you really find that you analyze the crime scene, what happens along the way? How is the way you work changed further down the road?
It changes a lot, because you can visualize a large and complex set of information. So you can actually reduce the workload for the prosecutor, for example, and the investigator. And compare this to, if you compare Drottninggatan, for example, if they hadn't had the 3D model, you have a pile of paper and a pile of pictures. Instead of page 32, you can see that, and on page 64, you see that. Here you can actually, everybody in the room sees the same event, at the same time. And
it's a common starting point for the analysis or the dialogue or the investigation.
And I think also the human-centric view is really important, because as we shown in Drottninggatan, you can see it from the perpetrator's view, and then you almost can see what he was thinking. And that's actually a horrible video, because they took away all the bodies and the blood, but you can still see that the truck sort of changed in speed when something happened.
Yeah. And now you're moving on to explore another generation of applications, another generation of digital twins. You call it smart twins. What is it that is smarter?
Yes. So we started with digital twins, and then we, through this example that I showed here, we actually proved that there is layers and layers of information. There are so many sensors, there are so many machine learning and deep learning algorithms that you can apply to support an operator. But still, there is even more you can do. Here we just took we took a large complex area, we went there with all the sensors, but what you actually can do is you can tailor it for the end user's need. So you can put a human in focus. What does a human need? So the picture you see up to the left, this is a real multidimensional model. This is forest. You have a high resolution model of the forest. It's classified and labeled what kind of terrains it is. And then maybe this area could, for example, be identified as a very high risk for damaging the environment. There could be species or very rare kind of birds, etc. Or it can be a high risk for firefighting, for wildfires. So here you can actually start with a 3D model, like a digital twin. Then you can add information as an event occurred. You can have a deploy sensor that actually detects if there is smoke, and then you can provide that to command and control center, and then you can sort of support the drones with coordinates, and you should go here, and then you can have IR sensors on drones and say that it's very difficult to see through smoke, for example. So the picture up to the right is that you can actually send coordinates to the firefighting aircraft. It's a problem to drop water in the smoke because you don't see very much.
No. So this is an agile process where you add more and more information and intelligence, but it's tailored. It's a tailored application, in this case, to the helicopter driver or the firefighters, and then you can make them a lot more smart. You make them smarter. Less water is spilled. More precise operations. What else are the benefits?
The smartness lies in that you actually provide the end user with the information that is needed, because a wildfire is an event that rapidly changes over time, and you want to detect it as early as possible. But we focused on rural twin because there is a lot of focus on urban areas, medical twin and models of urban area. But cities are expanding very rapidly. So you can, for example, use it for city planning. If you have an area where there is need for archaeological investigation, you can document it, you can analyze it, you can actually preserve a digital twin to the aftermath, to people to see at museum, and actually walk in ancient buildings, for example. And you can monitor forest. And I mean, a huge problem in wildfire is insurance. You can actually measure the forest. This forest is of a certain value before a fire. After the fire, you can actually measure how much is damaged, and then during the fire you can actually try to prevent as early as possible for the fire from spreading. So,
and then you can work in real time, which is
absolutely
a real advantage.
Yeah.
If you and your team had more resources, more time, what kind of work do you need to do more of now in order to be even more innovative and more relevant in your applications going forward?
I would like to see this sort of smartness for not for sort of crime scene documentation, but the entire chain. Maybe you can have a drone on the roof on the police car. That's my vision, my personal vision. I would like all the police cars to have a drone with a lot of fancy sensors and So if a police officer gets an alarm, you can send a drone as a first responder to
ahead also.
Yeah, and then you can send. That's a simple, very simple request. What is happening, and you can get pictures, and you can see the situation. So you can support back office to the police officers, and then you have the whole chain. Is there a crime? If a crime happened, you can document the scene, and then you can see where the crime scene investigators should work and what evidence they should collect. You can use the camera to find body liquids like sperm or blood or saliva or so on, and then you can use it for prosecutors. So I would see smart twins for the entire chain, and what we really want to achieve is to prevent crime and be better, have better capability in solving crimes.
What I see, Lena, is almost like a person being kind of augmented by a whole team from the side, from the back, from everywhere, supporting that front figure in doing his or her work more proactively, more accurately. It's like you're adding so much capability in real time. It's amazing. We're going to talk more. Thank you so much.
Yeah.
Join us later again. So I'd like you to go. Yeah, I'll take it. Let's talk about the next phase of virtualization, from a digital twin to a virtual twin, and the opportunities with a hybrid solution. Please join the dialogue the Managing Director of ESI Group, Jonas Fredriksson.
Thank you, Beata. Happy to be here.
I'll give this to you because
Okay.
you also have stuff to show us.
Thank you.
Tell us more about the opportunities when working with a hybrid twin
Okay.
and what it is.
Yeah. So for us, a hybrid twin is a combination of a digital twin, as we heard, and a virtual twin. So a digital twin is built, as Anders mentioned before, capturing historical data, maybe putting some data analytics into this using sensoring, and then what we've seen from Lena, we could then illustrate what happened in the past. A virtual twin is a representation of the future. So we could build a virtual twin of a product or a process or a scene, and then we are combining models of materials, models of systems, and this is a little bit where we are coming from ESI. We started doing crash simulators in the early 80s.
And I love it because it's like you can fast forward and back, but the forward doesn't end with now. You can look into the future, what's going to happen, say, with a truck or with a building. And can you give us some examples of applications where this could be useful?
Yeah. So for example, if we develop a virtual twin of a car, for example, or a system of a car, then we could represent something that has not happened or that is present today. So we could use, as we see here, the possibility to use 3D models and illustrate the car and how you could open the truck and how you could interact with the truck. If we then would like to combine that with historical data, then we could fast forward, as you said, and we could look into predictive or prescriptive maintenance, for example.
Do you have another example?
Yeah, so it's also about equipment. So what we see in this simulation here, it went a little bit fast.
It's here when you just see the hands.
Yeah. So what we have done here is really also looked into the equipment in the factory, with kinematics and collisions and interaction. And doing that, then we could, let's say, validate the model very early. And we don't want to do that as a simulation. We would like to include the human into this to get the human perspective.
Just stop that. We don't want to do a simulation because the difference is that when you work with a hybrid twin, you're working with the real thing, and you can include, say, the service technician, you could include an engineer, and you are working with the real thing, so to speak.
So for example, the guy, my colleague Eric, that we see here on the scene, he is, let's say, representing, or could even be, the worker from the shop floor. And by providing this virtual environment, we don't present for the worker what will be the future. We involve them, invite them to take part of this, let's say, virtual arena. So they could take all their experience and their knowledge, and they could come into this a virtual cell or virtual line and try out virtually how it will be to assemble this product moving forward. So then instead of presenting for them and using simulations with human, we involve and include the human perspective into the validation.
So much more engaging.
Yeah, and it's also...
And you can see what kind of training opportunities or training needs to happen.
Yeah.
What do we need to explain? How can we work even closer together? There's so much you can understand by doing this.
Yeah. So what we do then in the next step, for example, when you start up production, we could then involve people doing process optimization. We could look into ergonomics aspect. We could secure we are interacting also between people in one physical location, but also people that are present somewhere else in the world.
Yeah. And during Corona, when there's been travel bans and not so much opportunity to meet in person, I know you've also arranged kind of virtual factory visits and cooperation of teams in a virtual environment. Can you tell us more?
Yeah. So the companies we work with, in the past they were traveling around the entire world. They were looking into physical products and physical facilities. Now we could invite them to take part of this virtually. So we could have a person in Bangalore, a person in Gothenburg, a person in US, and they could meet here and talk about the different, let's say, challenges and do the validation, what we call then real-time human-centric. So that is of course removing waste, it's removing the impact of the environmental, and we are also helping the companies to reduce cost and time in the development cycle.
Do you have a film to show that?
Yes, I think we had a film to show that. I don't know where it disappeared. Could we play the film 2, please? So the second part of the first movie where we see the interaction between different sites.
Let's talk
Okay.
more about what happens, because you've seen this now. What happens when you have a team work, not with a simulation, but in real time?
So we see we could find problems much more easier. So for example, we had a case, we will come into service situations where the service engineer have tried to explain for the designer that this is a design that will not work at all. They use PowerPoints or they communicate or they talk, but they are not connecting. When inviting that designer to be virtually performing that service operation, it took 2 minutes more or less, and then they were on the same
You
page.
see it with your own eyes, or
Yeah.
you experience
Yeah.
it.
So we call it I see, I do. So we would like, to interact in the virtual world.
And for example, maintenance. What do you think maintenance will look like in the future?
Yeah. So bringing this into the maintenance, here we have an example from aerospace. So it's an airplane that has been designed. We would have been able to, let's say, validate how to change a component in order to secure that when a plane comes to the airport and they would like to do maintenance, that we are shortening that time. But taking this also with, let's say, the digital twin, so when a truck will come to a service point, they could download the virtual representation of that unique car or that unique track or airplane. They could also load the data coming from the sensors and then
Of
predict
the real
of
truck?
the real truck, yeah, and then do maintenance on the components that make sense. So today we are putting our cars once a year and changing something that we have been simulating before. Now we could even predict that, knowing exactly what has been, let's say, used and what has been, let's say, not working well, and then be more on the task and the topics to replace that.
So everything becomes more real time, but also more precise in a way.
Yeah,
And speedier.
Yeah, and also instructions as you made. We instead of training all, they could be trained on demand. And there is for trucks and airplanes are so many variants. And here we could then use maybe 10 minutes before going in put on the VR goggles, or even use augmented reality to support that type of service situation.
And help us and guide us what to do.
Yeah.
You know, when you talked about that team and the service technician trying to convince the designer that a certain design didn't work, I'm thinking about how expertise is kind of more evenly, how you enable that to be more evenly spread, because the person with kind of the insight has visual proofs and more of material to show and interact and engage with, so that you don't have to be sort of managed, but you can take your own decisions. What's going to happen to expertise?
So I think expertise, this is what we would like to sustain with a human-centric approach. So of course there is a lot of AI coming in to support this, but I think in the end of the day we always need to have the human perspective. And by combining, let's say, the virtual twin, the digital twin with AI, and then allowing them to experience that. So as we see here, we are looking into democratizing this. And people
What do we see here in this film,
So
Jonas?
today we see two persons that are connecting with wireless headsets. Today they are in an office. They are going around a virtual track, experience the product for a service or assembly manufacturing possibility. But in the future, we might use it with 5G instead. People are working from home, they connect from anywhere, and they would like to come together. It could be 2 persons, it could be 10 persons, and by doing that we could shortcut so many decisions, and we could save a lot of let's say, time, but in the end, to capture and involve the person, I think is important.
There will be no backlog.
No,
Maybe,
and we
hopefully.
will always also avoid the problems.
Yeah.
Because we could remove them before they happens.
This is so brilliant. I'd like you to join Lena Klassen from Swedish Police
Yep.
Authority, and we'll have a dialogue about, why don't you go ahead?
Thank you.
And we'll have a dialogue more about what kind of applications you see when the capabilities of a team is augmented. When you have this kind of augmented support around you, in what way is the way the team work? In what way does that change, Lena? What do you see? Would you mind stepping a little bit there, and Jonas more in the middle? Thank you so much.
So, I think it's extremely important that in a critical situation, for example, all the team members have the same information. That's real critical. So you can actually support a team, and you can support back office by sort of providing time critical information, but you can also support them in a very dull and boring moment, see if a wildfire is really if it's really gone out, or if it's gonna blow up again. That's you can use sensors for. So dull, boring, dangerous, time critical moment to ensure that everybody has the information required at the moment and the same information.
To use very profane language, it will be more fun because it will be more engaging. You're not so much dealing with problems arise. I mean, you can be more, you really be more relevant and accurate in a way.
Yes, and I also can foresee a lot of sort of, you don't have to look in your different Excel spreadsheet and mailboxes and where did I have that, and so you can actually integrate all the information in a smart digital twin.
Can you tell us more, Jonas, from your experience, real-time collaborate decision making? How is that changed? Like, what does it look like when everything is real time? I mean, decision making today is a linear kind of process usually, over time, sometimes very long time. What happens when that period is shortened and everyone has the same information?
So what we are able to do is to enable and give this possibility to people right now. So looking into the past, people were sitting together, looking into problems, and then defining a need of doing a simulation. And then you had the time to build up that model, to simulate that model.
Which could take weeks and months.
Weeks and months, and to get that result. And then let's say the result might not be valid anymore. So what I think is important is to create a virtual representation of the situation as accurate as possible. And it could be a crime scene, for example. If you could go into that crime scene using both a digital twin and potentially add the virtual twin looking into scenarios and alternatives, you could take the decisions right now. It's cross-functional and it's also cross-site. So if you would like to involve someone sitting in another part of the world, they could also come in and be part of that crime scene or that development situation.
What happens to power and to the power over decision making?
Power over decision making. Can I just make a comment
Yeah.
first? Because our problem at the police forces and forensics all over the world is that when you provide new technology, you also provide new means for making crime. So new crime evolves as technology evolves. So what we're going to foresee, what we probably could work together in the future, is autonomous car. Because that could really be what really happened. I mean, the driver is still responsible as a sort of owner and sort of driver of the car, even if the car drives but itself. But what happens if they get hacked, or if the cooperation between the car, interaction between the car doesn't work? So I can see a lot of need for new interactions to new partners. So I don't.
And then you need to work, of course, interfaces so that other parties can interact and can share and can participate in the work process. I'd like to invite now innovation advisor from Linköping University, Karin Ackerholm, to the dialogue. If we just make some corona space in our group here, in our circle. Hi, Karin. Hi. Your job is to support researchers reaching out with their research. And what kind of interesting research is happening in at Linköping University at the moment that could be applied to the area of visualization?
I would say we have a good position also in that Linköping University is a broad university. So we have both, as has been mentioned, this with expertise and expert knowledge. We have knowledge that can be applied with these techniques and where knowledge developed at the university could be used for application. But we also have these technological advanced projects where the actual application happens. So both sides. And I work as an innovation advisor. I'm also involved in the recently started East Node of AI Sweden. And that's a national initiative to accelerate the application of AI. And I think in that field, as well as in the fields that we've discussed so far today, there's a lot to be said for exploring and co-creating, as it were in the recent dialogue, these solutions to make sure they make radical and relevant change in society.
And how do you design those partnerships or collaborations so that they're innovative and successful and provide the right kind of output?
Well, for one thing, I would say that we must understand that we're working with these complex issues. I mean, many of the things where we could see that advancements could be really beneficial. For example, where we have challenges today, we would need expert knowledge from multiple fields. And we also need the actual experience, like was shown in Jonas's examples, this with actual working experience of that context where things are to be applied. So therefore, you must understand the situation that you're working towards enhancing to actually accumulate the knowledge that's relevant. And I think Lena's examples is also very relevant to show that it's very much in the heads and the minds and also the working practices of these domains where you can see the actual value, and you need to have those competences collaborating in actually creating this value, because otherwise we end up with desktop products that are technologically advanced but still not really delivering value, and that's a risk I see.
You've been working a lot with cross-disciplinary and cross-industry initiatives. Are there insights from those processes that can be applied to the area of 3D visualization and digital twins that you would suggest that we look at?
Well, I think some of them have already been discussed, but I think it's also this with moving across boundaries. That's where you sometimes say that creativity is combinatorial. It really is where we meet disciplines where we can actually enhance both disciplines or move ahead in these domains. So therefore, understanding where digital twins are not applied today, where we don't have this technology and where there are leaps to be made, is one part of the issue. And that knowledge perhaps resides in people who are not knowledgeable about this field. So getting out of the building, like you say, and actually understanding where are these complex issues that can be explored and perhaps also enhanced with these solutions.
So from your experience of disseminating technology, how could digital twin technology reach larger audiences or larger user groups so that we see applications being developed in more areas?
I think, like I mentioned this with AI Sweden's initiative of actually building partnerships for exploring technology and also for actually getting them out into society so they don't end up nice proof of concepts but not necessarily in active use. That's one thing. So actually actively involving partners. And then also understanding that these issues are as complex as they are, therefore not limiting our scope of this, but also getting help and assistance in examining the problem area, like Anders was mentioning, before you actually move into this, to understand if we, for example, need a geologist on the team, or if we need somebody involved in city planning, because we might not have thought that that was a competence we needed, but since the application is supposed to be useful to them, then yes, we should have them on board.
Let's spend a few minutes talking about what societal challenges we can solve with smart twins. I'm just going to help the audience by inviting you to the next opportunity to ask questions, which is the slide called Ask Questions to the Panelists. If we could have that, perhaps Ulrika, if you could assist me talking to the staff behind the scenes. And I'm seeing, I think we have it, yes. If we could have that, if it's possible. So what societal challenges could we solve with smart digital twins in areas that we are not addressing today? Do you want to start, Jonas? Have you been thinking about this question?
I think back to a little bit what you said, Lena, before about autonomous cars. I think there we could also look into possibilities to, let's say, create a virtual twin or a simulation, and how that could help the society to replace certain situations that are, let's say, dangerous, or that are potentially creating a situation that will end up with injuries, or even, let's say, take away waste. So I think there is a lot of positive things to be more efficient using the digital twin with the historical thing, and look into different type of, let's say, use cases coming from the players in the industry.
And how do we collect those how do we jointly address large critical societal challenges? Do we need to change the way we collaborate, the way we work?
Yes, I think so. And sometimes also which players we do collaborate with. I mean, understanding that the logic of how we build these consortia or the collaboration teams is also relevant to think how we actually enhance knowledge in that field. For example, we have had a project recently at our unit where we work together with civil rights defenders. So they're a human rights organization, and that is in the field of innovative, which is strange, but it's not these kind of issues that we've been working closely with. But also I see a lot of potential in the collaborations where you see research teams moving across borders, for example, thinking of how these technologies can be used in medical domains where we might have, due to lack of data or possibly also human biases, overlooked certain areas. Thinking of, for example, where we don't have data on female bodies as much as male bodies, because we don't dare to experiment with these systems producing babies. But also thinking of things like, for example, medical applications, the possible impacts of those on a societal scale, or other technology on a societal scale. That's the kind of things that we could actually elaborate using a digital twin.
And I think what you mentioned, also looking into new use cases, so we are working a lot with industry, aerospace and automotive, but now I've been listening to the police department, and I think there are a lot of useful use cases for society where we potentially, with our knowledge and experience, could help and support, and then working together with the university, we could find use cases that really could accelerate the way we work together.
What are the real societal values and opportunities that we could address?
I think we all want a very equal and safe society. So I think that all the application we have heard can actually contribute to that. If we, for example, from the police can apply this technology, we can create a safer community, and then we can focus on environment. So I think that there is a lot of benefits that we can do, and this is extremely rapid technology-driven development. But what I think the key issue is two words: human-centric and interdisciplinary. As you mentioned, Karin, we need to find the person who has the actual problem, and we need to use the best. And we have a lot of excellence here in the region and in Sweden, all of Sweden, and bridge that. I think that's the major challenge that we foresee, for example, in the Swedish police. There are a lot of technologies here, and we're not unique in having difficulties to implement it and bring it into the daily use. So the thing we showed here with the sort of digital twin for crime scene is a breakthrough, and I'm very happy for that. But more of that, more interdisciplinary, more interaction, put people together and focus on the real problem. Technology is fun, but I mean, we have to reverse it and put the human in the center.
I'm thinking a lot about the way we work. When we work in a reactive way, we have something that we need to solve because it might be something that's affecting us, and we have it. But when we're working in a proactive way, when we're predicting, forward-looking, it's a much more kind of investigative way of working. You try and look for different kinds of rights. You don't have. No one is right from the beginning because that's the nature of explorative work. You're smiling here, Jonas, because you recognize the. But well, my question is, what are the challenges? Are there mental barriers, or do we need to set up new ways of rules for collaboration? What's hindering us from being more explorative?
So I think there are different challenges. One challenge that I was thinking about here is the data. Because we would like to capture a lot of data in order to create the digital twin and predict the future. So we are putting sensors everywhere, cameras everywhere, but we don't really know what we are looking for. So maybe we first need to create a virtual twin of the different scenarios that we would like to avoid, and using that to also design the system for the digital twin. So where does it make sense to put the sensor? What type of data do you need in order to predict something? So I think that is one challenge that is obvious, because otherwise the resources are not enough to capture everything. And I think that could be a good combination to first try to understand what do we want to collect and how do we want to use that, and then we could design the system.
Lena Klesén?
Yeah, I think that from the police point of view, we can be very proactive because if we can solve more crime, then we will be able to prevent more crime, because crime doesn't pay. But I came to think of more than 100 years ago when people had horses. So what you really want, if you ask the people what they want stronger and faster horses. And if we should listen to them, we would never ever have come up the idea with the cars. So I also think that we need to go outside the box. And I think that very much is tradition. We do things in a certain way because we've done that for 100 years. But maybe we can help with sort of really new invention that really change society. I mean, digital twin and smart twin, that's really a possibility. So we mustn't sort of get stuck in the old way of thinking. So we should actually use the possibility or do something completely different.
Have you seen examples, Lena, in your organization and in your team when you've leaped and you kind of had that stepping outside of the box, and what happened there and why did that occur?
I worked at Saab defense system some years ago, and then when we realized that we were sort of falling behind on the technology development, we realized we don't have to go through the first and second and third generation to catch up. So if we had the product 1.0 and the rest of the world had 3.0, we could actually go for 5.0. And so we did on radar system and lidar system, and we were sort of thinking out of the box. So that's I like that idea. So go beyond.
Is that a leadership question?
Yes.
Yeah, absolutely, because you need a very brave management. So yes, go ahead, but don't fail. So it's very much a management question. You need brave leaders that actually dare to do that.
But this makes it easier to fail in a way, because you're failing in a controlled way when you're working with a digital or a virtual twin. You said yes when we talked about leadership.
No, but I want to say that that's also in entrepreneurship and innovation. This factor of daring the leap is, of course, an integrated part, but we also sometimes use and describe these things of leadership qualities and the bravery in perhaps the wrong way. It's not necessarily brave to do something new, because it might end up only, if I dare say, an invention. It might not be an innovation that actually has, adoption widely in society. But usually it's like daring out of your comfort zone, meeting people with other knowledges, understanding the things that you don't really want to know about your problem, product, like for example the risks or the possibilities that could go wrong. It's also daring to see those, with your actual process, understanding that this is something we need to be handling, and therefore these scenarios, daring to see them, but also having people with other knowledges pinpoint that this is not good, or that's daring in another sense. It's like exposing yourself, saying like, this is my invention, now come hack it up in small pieces, and not crying about it, but go like, okay, so it's Lego, we'll build it back.
Yeah, you're really spot on, because you need to be preciseless.
And I'm also encouraging you to go to menti.com and use the code 11335339, menti.com. No need to download any app, and you can ask questions or give comments or examples that we can share with our panelists, menti.com. What would you like to spend more time on in order to find new ways of working? Back to what's hindering us from really leaving the old ways of working to going to what you describe, Jonas, as a kind of a democratized, real-time, engaging, only doing what's necessary type of work environment. What would you like to do more of if you had more time?
So I think open collaboration is important, and also create arenas where we could meet together. So today is one example of an arena where we are starting to, let's say, break a little bit the silos. So there are different, let's say, parts in the society. Lena is working in her box, I'm working in my, and Karin in her. But listening and talking together, we could find and also reuse and leverage things that we have done in different ways, and maybe come up with new ideas to use that. So open collaboration and arenas to foster this culture, I think, is really important.
Lena Claesén?
Yes, and I will immediately come up with the problem. but there is solutions, because working at governments all over the world, crime is very borderless. You have crimes that they work all over the world. But we, as a government, we have very restricted data. We cannot share the data, and that's a problem. But now so I would like to work more on like federated learning, where you don't distribute your data, you distribute the algorithm instead. So that's a key issue for us, that we need to work together, Försäkringskassan, Kronofogden, Skatteverket, police, and so on. So we really need to find a way to share information in a safe way. And also you addressed a very important issue, Karin, that if we use AI, all the databases that we use, they represent the world as it is. The word is not gender balanced. It's not a correct word. So we have to bear that in mind. So we don't want to use the data as it is, because we need to figure out a way how the word should be a better word.
How it should be.
Yes, so it should be. So if we use all these databases, we will come up with that there is an imbalance, as in your example of medical information, where the difference between men and women. So we have to be aware of that too. So that all the databases, they are not gender balanced, for example. So.
And maybe we could then generate more data. So instead of looking into historical data, we could simulate and produce a lot of data that could be used for AI.
That is such an interesting thought. And we'll be leaving you with that thought. If you could simulate data to improve the data quality of the data sets that you are working with, what opportunities could that provide you with? Who would you like to collaborate with to come up with better solutions or better applications in the areas where you are working? And back to the Professor Innemann's first advice is find a really good problem or perfect your problem so that your starting point for developing a digital or a virtual twin is a great one. That's my takeaway from this first part of the day.